Welcome to our deep dive into BigQuery streaming. Today, we'll explore both important concepts and provide a hands-on introduction to this powerful feature. BigQuery is a highly capable data warehouse, and there are many situations where we might want to stream data into it for analytical purposes. While data can come from a wide variety of sources, we'll use Python in our demo today as it's a convenient and beginner-friendly choice. We'll examine two methods for streaming data into BigQuery. The first is a direct approach, streaming straight from the Python into BigQuery. The second method introduces PubSub, a distributed asynchronous message queue which allows us to decouple our client from the BigQuery ingestion process. This alternative approach offers some potential advantages but requires a bit more setup. We'll cover both methods so you can decide which one best suits your needs. Let's start by creating a new project in BigQuery and setting up a new dataset. Imagine we're working on an Internet of Things or IoT use case. Once we've created the dataset, we'll make a new table called Occupancy to simulate an IoT occupancy sensor setup for a property. Our table will have a simple schema with the sensor ID and the number of occupants. We could also add partitioning and a timestamp field to improve our setup's customization. After creating our table, our next task is to stream data into it as if we were receiving data from IoT devices. We'll use a Cloud Shell editor to write our Python code for streaming into BigQuery. Before we start coding, let's discuss BigQuery's primary data ingestion method, the Storage Write API. This API allows us to perform streaming operations efficiently and smoothly. It uses a transactional approach, which means we can safely retry operations if they fail. It's important to understand that there are different types of streams in BigQuery, and each type determines when the data written to the stream becomes visible for querying. The first type is pending. Data is loaded into a stream buffer and becomes available for reading when you commit it. The second type is committed. Records are immediately available when written to the stream, providing minimal read latency. The third type is buffered, which is generally used with Apache Beam and not recommended for most use cases. For our demonstration, we'll focus on the committed stream type as it makes our data instantly queryable in BigQuery. Now that we understand the basics, let's dive into the coding process. We'll start by setting up our Python environment in the Cloud Shell editor. First, we need to install the BigQuery storage library, which we'll use for our streaming work. We can do this with a simple pip command. Pip install Google Cloud BigQuery storage. Once installed, we'll import the necessary modules and create a function called stream data to BigQuery. This function will take several parameters, dataset ID, table ID, and the data we want to stream, our rows. In our function, we'll first construct the table path using a helper function. Then we'll create a write stream using the BigQuery storage client. It's important to specify the stream type as committed here, as we want our data to be immediately available for querying. Next, we need to set up our append rows request. This is where we'll actually send our data to BigQuery. We'll use protocol buffers, protobuf, to efficiently serialize our structured data. Don't worry if you're not familiar with protobuf, we'll walk through the setup process. For our IoT occupancy sensor example, we'll generate some sample data. Each row will contain a sensor ID, a random string of letters and digits, the number of occupants, a random integer, and a timestamp. We'll use Python's random and datetime libraries to generate this data. Once we have our data prepared, we'll send it to BigQuery using the append rows method of our client. This method takes care of streaming our data into the table we specified earlier. It's worth noting that setting up the protobuf schema and getting everything working correctly can be a bit tricky at first. If you encounter any issues, don't worry. It's a common experience when first working with this setup. Remember to check your imports, ensure your schema matches your data structure, and verify that you're using the correct data types. One interesting quirk we discovered during testing is that BigQuery interprets a value of 0 for occupants as null. This might not be what we intended, but it's good to be aware of such nuances when working with BigQuery. After successfully streaming our data, we can query the table to verify that our records have been added. You should see your data appear almost instantly, thanks to the committed stream type we're using. Now that we've covered the direct streaming method from Python to BigQuery, let's explore our second approach using PubSub. This method adds a layer of complexity but offers increased flexibility and resilience to our data streaming process. To begin, we'll set up a PubSub topic and subscription in the Google Cloud Console. First, we need to create a schema for our PubSub topic. This schema will mirror our BigQuery table structure, but we'll use a JSON request format. Next, we'll create a topic using this schema. After creating the topic, we'll set up a subscription that will write data to BigQuery. When configuring the subscription, ensure you choose the correct endpoint type and link it to the topic we just created. At this point, you might encounter permission issues with your service account. To resolve this, we'll need to adjust the IAM, Identity and Access Management settings. Navigate to the IAM and Admin page in the Google Cloud Console. Here, we'll edit the permissions for our service account. For simplicity in this demo, we'll add the BigQuery admin role to our service account. In a production environment, you'd want to be more selective with permissions, following the principle of least privilege. With our PubSub setup complete and permissions sorted, we're ready to use this system. Instead of using a Python script to stream data directly to BigQuery, we'll now send messages to our PubSub topic. These messages will then be automatically forwarded to BigQuery through our subscription. We can demonstrate this process using a simple bash command with the gcloud command line interface. In this command, occupancy is the name of our PubSub topic, and the message is a JSON string containing our sensor data. When we run this command, we'll receive a message ID in response, confirming that our message was successfully published to the topic. This approach is quite efficient. Instead of running complex Python code, we're simply emitting messages to PubSub. The cloud infrastructure then handles the process of moving this data into BigQuery, reducing the load on our client-side systems. Of course, you could expand on this basic example. You might create a more sophisticated script in Bash, Python, or another language to generate and send messages. As long as your script produces JSON formatted messages that match your schema, you're good to go. After sending some messages, we can check our BigQuery table to see if the data has arrived. In our example, we should see 4 records, confirming that our JSON data has successfully streamed through PubSub and into BigQuery. The PubSub approach offers several advantages over direct streaming. Let's explore why you might choose this method. Decoupling. PubSub acts as a buffer between your data source and BigQuery. This means that if BigQuery is temporarily unavailable or experiencing high load, your messages will queue up in PubSub and be processed when BigQuery is ready. This decoupling adds resilience to your data pipeline. Scalability. PubSub can handle massive throughput, making it suitable for high-volume data streaming scenarios. Fan-out. With PubSub, you can easily send the same data to multiple destinations. For example, you could stream your data to BigQuery and also to a real-time analytics system or a backup storage solution. Error handling. PubSub allows you to set up dead letter topics for messages that fail to be processed. This gives you a way to handle and investigate problematic data without losing it. Flexibility. You can add additional processing steps between PubSub and BigQuery if needed, such as data transformation or enrichment. When deciding between direct streaming and using PubSub, consider your specific use case. If you need a simple, low-latency solution and don't anticipate needing the additional features of PubSub, direct streaming might be sufficient. However, if you're building a more complex data pipeline or anticipate needing additional flexibility in the future, the PubSub approach could be beneficial. As always, we'll provide all code and the diagram illustrating this setup in the video description, along with a link to the diagramming tool, which you can use via a free trial. We'll keep an eye on the comment section for any questions and want to thank you for watching. Please enjoy responsibly.